Hello everyone. So in this video we will learn to solve the knapsack problem using dynamic programming. Knapsack problem is a problem where we have one knapsack. Knapsack is a container and our interest is to fill this container with the item with a maximum value. So knapsack problem is an optimization problem where we want to maximize our uh, profit or maximize our gain. So in the previous video we have seen to solve knapsack problem using greedy approach, and we have seen that the greedy approach is giving the solution for this problem, but the solution is not optimal. So in this video we will see that how the greedy approach not guarantees to give you the optimal solution, and then we will applying the dynamic programming approach to get the optimal solution, the best solution. So dynamic programming basically is used to get the optimal solution. Two basic features of dynamic programming is memorization and optimal substructure. Optimal substructure means to get the optimal solution of a problem, we are uh, trying to get the optimal solution for sub-problems of the same problem. And memorization is a kind of concept where we are using some memory, some storage to store our intermediate results, and these intermediate results are used throughout the process to reduce the running time. So we will see how to apply this approach in solving the problems. Okay, so here we have one problem where we have one knapsack with capacity 13. We have 4 items with their weights and cost, and we want to find the optimal solution. In the previous lecture, in the previous video, we have seen that we can solve the knapsack problem using a greedy approach, but here we can see that greedy approach is used to solve the problem, but it does not guarantee to give you the optimal answer. How? So if I am going to solve the same problem using the greedy approach, the first thing is I need to find out the priority of each item. I need to find out which item is more important. So for that I will be listing the items like this. For example, these are item 1, item 2, item 3, item 4. We have 4 items and their weights are 5, 6, 8, 4, and the cost of each item is 5, 4, 7, 7. So first I need to find out their value, means the importance or the preciousness of the each item. This can be find out by this ratio cost upon weight. So this is 5 upon 5, which is 1. You can say 4 by 6, and then this is 7 by 8, and then 7 by 4. So we get these values on solving this. So if you look at these value for this item, you can find that this value is maximum. That means this is the most precious item. So if I have to make a choice to pick any item, I am going to pick item number 4, the very first choice. This will be my first choice because of its preciousness. So I am going to assign a priority. This is the priority 1, the maximum value. Then this is priority 2, then this is 3, then this is 4. Means in this order I am going to pick the item to get the maximum profit. So based on this calculation, I am going to pick item number 4, the first item, which is having a weight 4. Now the total capacity of the knapsack is 13, so 4 weight is already filled. So I am going to the next item. The next item I am going to pick is item. The next item I am going to pick is this item number 1, because this is the second priority. So I go to item number 2. So the second item will be actually the item number 1, which weight is 5. So now so far I have filled 9 kg in my knapsack, and still I can fill another 4 kg. So I am looking for another item. So the next priority is item number 3. So item number 3, the weight is actually 8. So this I cannot take because I need only 4 kg. So I'll go to the next choice, which is item number 4. So item number 4 is again 5 kg. So again I will not take this. So the total weight I can keep in my knapsack is 4 plus 5 9, and the value which I am getting out of this is, the value for item 4 is 7, and for item 1 is 5, that is 12 I can get. So if I am solving this problem using the greedy approach, my answer would be that I will be picking item number 4, item number 1, and I am getting the gain as 12. But if you look thoroughly to this problem, and you can easily check that this is not the optimal solution, because if I would have taken item number 3 and item number 4, item number 3 and item number 4 whose weight is 8 and 12, this is combination is still possible, because combination is still possible. And if this is the case, if this would be the case, then in that case the gain I am getting is 14. 7 plus 7, 14. So in the greedy solution gives you the 12 value, but the optimal solution will give you the 14 value. So we can easily see here that greedy approach does not give you the optimal solution. It may give, but it is not guaranteeing. So now we'll see the dynamic programming approach that always gives us the optimal solution. So here we will be using a kind of you can say formula which help us to get the optimal solution to the dynamic programming approach. So what is given here, we are giving the items with their weight and also with their cost, and the knapsack capacity is M. So we will be using this formula. We are going to make a kind of matrix, something like this. We are going to make a matrix, and in this matrix we need to fill these cells. Now how to fill these cells? This column wise we are arranging the weight, means if you go look at this column, so this will be representing the weight, and if you look at these rows, they will be representing the items. So we need to find out CIM. This I is for the item and M is for the knapsack weight. This is a capacity of the knapsack, and we are interested to fill these cells CIM. So now let us look at these values. When if I equal to 0, means if there is no item, and if there is knapsack with 0 capacity, then we are getting nothing out of this. If there will be no profit, no gain we are getting. So this is 0. If weight of the item is more than the knapsack, if weight of the item is more than the knapsack, then in that case you will be getting Ci minus 1 M. That means you will take the value of the previous item. This means Ci minus 1 means previous item. Whatever the item you have taken so far, that will give you the maximum gain. The new item is not going to contribute anything. If Wi, if the item weight is more than the knapsack. The third case is if the item weight is less than equals to, this will be actually equals to the knapsack weight, and if the item is there, then we have to make a choice out of two combination. This is one option, this is second option, and out of this we need to take the maximum. Now what is this? So whenever you are going to pick any item whose weight is less than the knapsack, then we have to check the value of this with the value of this item. The value of this item, this is the value of the item which you are going to check, and also you have to find the value of the remaining weight, the value of the remaining weight. So let's say I have a knapsack capacity is 9, and you are going to pick item whose weight is 6. My capacity is 9 and I am going to pick an item with weight 6. So I will take the value of this item plus the value of the difference. So 9 minus 6 is 3. So I will take the value of 6, means the item whose weight is 6, and also the value of item whose weight is 3. So this value we need to take. And the second option is we will be taking the previous, means if we don't consider this item, then what is the profit we have got so far. So we need to find the maximum, whichever is maximum. So let's say when you solve this, you are getting this x and we are getting this as a y, and if x is more than y, we will take x, otherwise we will take y. So we'll take the maximum out of these two values. Now we'll see how to make use of this given information. We will take one example, and also we note before we go to the example, we will see that running time and the space will be big O of n into w, where n is the number of items and w is the capacity of the knapsack, because we are going to make a matrix of this order, n cross w. Okay, so let us assume one problem. We have a knapsack capacity 5 kg. We have 4 items with the weights and costs are given to us. So we are going to make one matrix. The matrix size, the dimension of the matrix will be find out by looking at the capacity. So whatever the capacity is given to you, we will add one more column. If the capacity is 5, we are going to make 6 columns, and the row will be depending on the number of items. So we have 4 items, we will take 5 rows. So in our case, we are going to make a matrix of 5 cross 6. We are 4 items we are having, 4 plus 1, and we are having capacity is 5 plus 1, 6. So we are doing like this. So this particular column is representing the weight of the knapsack. So we start with the 0 weight. We have assuming weight 0, weight 1, weight 2, weight 3, weight 4, and weight 5. And these rows will be representing the items. So we have no item, 1 item, 2 item, 3 item, and 4 item. Similarly, we can also write the information about the weight and the cost. So this column is for the weight. So item 1 weight is 2, this is 3, this is 4, and this is 5. Similarly, the next column is for the cost of these items. So item 1 cost is 3, this is 7, this is 2, and this is 9. So how to solve this particular matrix? As we know that dynamic programming works on the optimal substructure property. So before filling the knapsack with capacity 5, we are interested to find out the optimal solution for capacity 4, capacity 3, 2, and 1. So likewise, we are solving optimally each sub problem to get the final optimal solution. So here, so we will be filling these cells row wise. So initially this 0 means that we have no item with us. So when you have no item given to you, then you will not get any gain or any profit, because we are not filling our knapsack with any item. So this will be 0. Similarly, this means that we have knapsack capacity 0. Means if the knapsack capacity is 0, and although we have 10 items, 20 items, we are not able to gain anything, because we are not able to put any item in the knapsack. So we are getting 0 here. Now we will move row by row. So now we have only 1 item. Now when I say 1 item means we are assuming that only 1 item is available to us, and we are interested to find out the gain we can get out of 1 item. Then we take 2 items, then 3 items, and then increasingly we can increase the item. So initially we have only 1 item available with us. So if I have 1 item and the capacity of the knapsack is 1, and you can see here the weight of this item is 2. So when the weight of the item is more than the capacity of knapsack, this time the capacity of knapsack is 1, the weight of the item is 2, which is more than this, you take the previous value. You take the value of the previous cell. So the previous cell is 0, so here you write 0. Now we move here. So now we have only 1 item available with us. Capacity of the knapsack is 2, weight of the item is 2. So we are into this. This is actually when the weight is less than equals to m, we will be into this case. So here you have to make a choice. We will see what is the value. The value of the item is actually 3, So you can write 3 plus, what does this mean? This means the value of the previous cell when you find a difference in the item. So this is 3, sorry, this is 2. 2 is the weight of the knapsack, 2 is the weight of the item. Now what is remaining? 2 minus 2 is 0. So at 0, what you are getting is, you are getting 0. Again I repeat here, this means m minus wi, means when you fill the knapsack with this weight, what is the capacity remains in the knapsack. So if I fill this item with weight 2 in 2 kg knapsack, or with a 2 weight knapsack, what is remaining here? There is no space, means 0. So how to find out? You can just, in the previous row, you go to the 0 column and look at the value, which is 0. So this is 3 plus 0 is 3, and this is what? This is previous value of that cell. So here the previous value is 0. So we have to take the maximum of this 2. So 3 and 0, we take this as maximum. So I will write here 3. So that means that I can be able to put my one item in the knapsack with capacity 2 to gain this value 3. Now because we have only one item available with us, we cannot improve this gain, because you can only put only one item, because we have only one item. So I am going to write this 3, 3, 3 in all the remaining cells. Now when I come to second row, that means now I am having two items with me, item 1 and item 2, and I need to decide which item I am going to keep in my knapsack to get the maximum gain. So I start now here, that means this means I have a capacity is 1 and item 2 weight is 3. So whenever you have weight of the item is more than knapsack capacity, you take the previous value. So we are here, previous value is 0, so you are at 0. Now again, capacity is 2, weight is 3. So when weight is more than capacity, you take the previous value. So you take the previous value, which is 3. Now when weight is 3, knapsack weight is 3, item weight is 3, you need to find out what to write here. So let me just clean this. So now you can see here, now we are at this cell and we need to find out what to write. So 3 is the capacity of knapsack, the item weight is 3, and we are in this case when weight is either less than equals to m, and also we are having item, so we have to check this. So the value of this item is 7 plus, and this is weight 3 minus 3 is 0. So we go to the previous cell and 0, we look into this column at 0, this is 0, so you write here 0, comma, and what is the previous value? The previous value of this is 3 here. So I need to decide the maximum of these two. So maximum of this is 7, so I am going to write 7. Similarly we go here. So here again the capacity of the knapsack is 4, item weight is 3, so I am going to write here, so how to do this? The value of the item is 7 plus 4 minus 3, 4, this is the capacity, 4 minus 3 is 1, so I'll go here and look at the 1 and the previous value, this is 0, 0 here, and the value at the previous cell is, this is for the value of the previous cell, this is 3, so I am going to take the maximum of this, this is 7 here. Okay, now we'll check for this again. Let me, here you can look, the capacity of the knapsack is 5 and the item weight is 3, so we are in this particular case, so we will find out the value of item number 3, and this item number 2 is 7 plus, now what does it mean? It means the value for the remaining weight, this is 5, the weight is 3, remaining weight is 2, so you go to the 2 weight and go to previous cell. We are in this row, we go to the previous cell, this is 3, so we'll write here 3, comma, and previous value, this is 3, so we'll take the maximum of this, that is 10. I hope now you understood that how to make use of this formula to fill this cell's value. Now we are in the row. We are in this row. That means now we are having 3 items with us: item 1, item 2, and item 3, and we need to fill the knapsack optimally. So here, when the knapsack weight is 1, the knapsack here it is 4, means the item weight is 4. Whenever the item weight is more than the knapsack weight, you simply take the previous value. So I'll take the previous value, this one. Here again, weight is 2, here item weight is 4, we take the previous value, this is 3, again this is also 7. Now this 4 and this 4, I need to decide. This 4 and this 4, we are in case 3, so we have to take the maximum of these two options. So the value of this item 3 is 2, so I like 2 here, plus, and this is the value of the difference. So difference is 4 minus 4 is 0, so I go to 0 and I will keep where this is simply nothing but 0, and this is the value of the previous cell, this is 7. So I will take the maximum of these two, the maximum is 7, so I will write 7 here. Now in here, this is 5, this is 4, so if I am going to write this is 2 plus, I'll go, the difference 5 minus 4 is 1, so I'll go to the 1 and look to the previous row, this is 0, and the previous is 10, so I am going to take the maximum of these two, I will write 10 here. So now we have a last row, that means now we have all the 4 items available to keep in the knapsack. Again we proceed in the same way. Capacity is 1 and the weight is 5 here, so we are going with this and we take the previous value only. So 0, here the previous is 3, is 7, 7, and now we need to decide for this. So here you can see that the weight, this is 5, knapsack weight is 5, item weight is 5, so we are into this case 3. So let us check the value of this item is, the cost is 9, plus, because there is no difference, that is 0, comma, and the previous value is 10. So we have to take the maximum is 10, so I am writing this 10. So this is what we need to do. Now we need to find out what is the optimal value we can get of this. So the value you are getting at the last cell, this is the answer, means the optimal gain is actually 10. We can get maximum gain is 10, we cannot get more than this. Now we need to find out what items we need to keep in our knapsack. How to find out this? We can find out by a defined procedure. So how we can do, we have to start from here and we have to compare this value from the previous one value. Now this is 10, this is also 10. Because the values are same, that means this item is not contributing. Now what actually we are doing, we are trying to find out what are the items which we need to keep in the knapsack to get this gain. This is what we have find out, that we can get maximum 10, but we have to keep in this, what are the items that we need to keep in the knapsack, item 1 and 2 or 2 or 3, this we are going to find out. So how to find out? We will start from this corner, the rightmost corner here at the end, and we compare this value with the previous value. If the values are same, that means that this item 4 is not contributing to our solution because the value is coming from the previous row. So we will just ignore this and we move here. Again we compare with this. Let us say this is not 10, this is, let's say 9. Let's say this is 9. In that case, we will take this item, that means item 3 is contributing to our solution, but because this value is coming from the previous, we will not take this and we will just cross this. Now we are here. Now here you can see that this value is not coming from the previous, means this value is different from this value. That means item number 2 is contributing, so item 2 should be in our optimal set. So this item is contributing to our solution, we will take this item. Now to proceed, we will check what is the weight of this item, 3. That means out of capacity 5, the 3 already we have filled the knapsack, So we need to look for the next item. So how to go to the next item? We will count here 1, 2, 3, and here. So we are here. Again, I am repeating how to check the other item. The item which we have already filled in the knapsack, look at the weight of the item. So this item we have kept in the knapsack, the weight is 3. So in the previous row we will delete 3, 1, 2, 3. So we are here. Now again the same procedure, we compare this value with the previous cell value. If they are same, that means this item is not contributing, but here this value is different from this cell value, that means this item is contributing. So we are going to write this item in our optimal cell, and then the weight is 2. So we will be in the above cell, we will delete 2 and we are here, and which is no item. That means our optimal solution is item 2 and item 1. That gives you the maximum gain. So you can apply this procedure in any weight and for any number of items with any capacity, and you will always get the optimal solution. So here we can see that knapsack problem can be solved either by greedy method or by dynamic programming, but greedy method is not giving you the optimal solution, but dynamic programming will always give you the optimal solution. Hope you have understood and you are able to apply this procedure in other numericals as well. Thank you very much.